right, so this is going to be the last video for this section 2.3, histograms, frequency, polygons, and ogives. Remember, we're still talking about or thinking about the same essential questions that we have been in the last videos, and these are the same essential questions that we'll ask or think about for the rest of this unit. And that is, how can we present data better? How do we know what graph to use? And how are different graphs more useful than others? All right, so this video, we're just going to learn one new thing depending on the type of information that's provided for us, or depending on how we're trying to compare two different pieces of information. And that is just going to be a relative frequency graph. So if we were comparing data from two different regions, let's say that we were talking about the age of people in Cairo that do something versus the age of people in my hometown, Pine Hill, that do something. There would be a lot more people in Cairo than there would be in my hometown, Pine Hill. We're talking about millions and millions of differences between them. So if we were to try and compare these two graphs together, no matter what information was provided, the Cairo would just look like because of the amount of people, the graph would just look so much different than Pine Hill's graph to begin with. So sometimes in order for us to compare the two pieces of information on the same level, same playing field, we need to take our relative frequency. All right, and we're just going to go ahead and figure out how to do that right now. All right, so this is just a quick example as to why we need the relative frequency. So if we look at this here, and let's say that we were doing a study on the people in Cairo versus the people in Pine Hill, and their type of hair color that they had. And if you look here, you say, well, 10 million people in Cairo have brown hair, and 7.5 million people have blonde hair, whatever. I was making these numbers up. And we say that 17,500 have brown hair in Philadelphia and Pine Hill, and 4,000 have blonde hair in Pine Hill. Now, because Cairo is a much larger city, you might look at this and say, oh, well, there's more people that have brown hair in Cairo. And you're not wrong with that, because, yes, there are more people. However, there are actually, in this one here, there's a higher percentage of people that have brown hair in Pine Hill. So it allows for us to then look at these two different cities, one that's way larger than the other, on equal playing ground. All right, and let's go through what we need to do for that. All right, so if we were given this table here for, I think this is the amount of miles that people run, right? So 5.5 miles, 10.5, and et cetera. If we were given this table here, in order for us to turn this into a relative frequency, the first thing we need to do is fill in all of our frequency that we have. So that will be, let me just pause this and fill that in. All right, so now when we want to find out the relative frequency, it's almost identical to finding the percentage. The only thing is you're not going to multiply it by 100. So here we have a total of 20 people. So our relative frequency, we would do the amount that we have for this mile, and we divide it by the total, and that's 0.05. So that is our relative frequency. For this one, we have 2 that ran that many miles, so 2 over 20. So this is then equal to 0.10. Right, so it's almost identical to the percentage, except for we're not multiplying it by 100. We're just going to write the decimal value. So let me go ahead and fill this in real quick. All right, so this is all of the relative frequency. And now if we were to graph it using these numbers, then we would be able to compare between the two, because then we can look and say, oh, well, although more people live in Cairo, so of course there's going to be more people with brown hair, just because we're dealing with millions versus thousands. But now if we were to break it down to the relative frequency, we could actually say, oh, well, actually there's more people in Pine Hill that have brown hair, as we had in this example here, because there's a higher percentage. All right, so that's what this relative frequency allows for us to do. And then another thing that we're still going to have to do is, at times, we'll still need the cumulative frequency, which is just going to be adding them up. So this one will then be 0.05. So 0.05 plus 0.1 will be 0.15, plus 0.15 is 0.30. So it's exactly like we had before, but now it's just decimals. All right, and we will just go ahead and add up all of these rows, and that will be our cumulative frequency. And this should end up at 1. The only way it won't is if there's something with rounding where maybe we end up at 0.99. If that's the case, then that's okay. All right, so let's go ahead and look at what some of these examples may look like. All right, so if you notice here, this is a histogram for the runner's time. Instead of using the frequency 1, 2, 3, 5, 4, 3, 2, we use the relative frequency. All right, so it allows us to look at the two pieces of information that we can compare them on equal playing ground. Instead of looking at the millions of people in Cairo and the thousands of people in Pine Hill, we can look at them as how frequently they occur. All right, so this is what it would look like with the histogram. Same thing for the frequency polygon. Nothing changes with this except for instead of it being frequency with how many, like 1, 2, 5, 8, etc., it's just a relative frequency. And then for the ogive, it's the same thing as before, but now it's the cumulative frequency, which is why we had to do that last part of our table. All right, so that's the last thing. Then the other thing that I wanted to talk about real quick is the different types of graphs and the different shapes that they can have. All right, so these are the different types of shapes that we can have. It's just good to know what's going on here. So our first one is a bell shaped, and that would be where it's where we have most of our data is in the middle, and then we have almost equal data on both sides, so it's symmetrical. If we were to draw a line down here, our graph will look symmetrical. Uniform means it's equally distributed about, like there's no peak. Like here in our bell shape, we have a peak. Here, there's no peak. It's just pretty much equally distributed. Another way that we can talk about is a J shape, where if all of our data looks like it's to the right of our graph and it gets smaller and smaller, it kind of forms this J, almost a J shape of a letter there. Reverse J shape, we can have it here, where it's going down and down and down, where it's going towards the right. Here we can have a right skewed and a left skewed. If you notice, the difference between these two is the most on our J shapes are all the way to one side, and it's decreasing or increasing as we go. And here it kind of goes increasing and then it decreases. So it's slightly different than the J shape. But when we say right skewed, that tells us where all of our data is decreasing to at the end. It's kind of the tail of our data. Here we go increase and then we're decreasing. So this will be left skewed because it's skewing to the left. So it's not where the majority of the data is at, like it is here. It's the reverse of that. So this one with the left skew, it's actually where all the lower data is. The right skew is here. Bimodal is where we have distribution, two different peaks that are at the same height. So if you notice, this has a peak here, then we have another part of our data has another peak here. So we have two separate peaks, unlike our bell shape where we only have one. And the two separate peaks are the same height. And then our last one is the U shape, which is what it seems like we form this letter U, where we kind of have our peaks on opposite ends. We decrease until the smallest part is in the middle, and then it's back up. It's kind of an inverted bell shape. If you notice, here would be an upside down U, here will be a U. All right, and that's it for this video, and that's it for this section.